Hey Matrix! Today, we're going to dive into the world of neural networks and learn about a crucial concept called backpropagation. By the end of this video, you'll understand what backpropagation is, its history, and why it plays such a vital role in machine learning. Ready to expand your knowledge? Let's get started. First, let's understand what backpropagation is. In simple terms, backpropagation is an algorithm used to train neural networks by minimizing the error between the predicted output and the actual output. It's like a teacher guiding a student to improve their performance by identifying and fixing their mistakes. To give you a bit of historical context, backpropagation was first introduced in the early 1960s by Henry J. Kelly and Arthur E. Bryson. However, it didn't gain much attention until the 1980s, when Geoffrey Hinton, David Rumelhart, and Ronald Williams popularized it in the context of training neural networks. Since then, backpropagation has become the foundation of modern deep learning. Now, you might be wondering, why is backpropagation so important? Well, without it, training deep neural networks would be incredibly slow and inefficient. Backpropagation helps optimize the network's weights, allowing the model to learn and adapt quickly. It's like the secret sauce that makes neural networks so powerful and versatile. So, how does backpropagation work? In a nutshell, the algorithm first calculates the error between the predicted output and the actual output. It then uses this error to update the weights of the network, working backward from the output layer to the input layer. This process continues iteratively until the error is minimized, and the network has learned the desired function. Now, let's talk about some pros and cons of backpropagation. One of its significant advantages is its efficiency. By using the chain rule from calculus, backpropagation efficiently computes gradients, making it a powerful optimization technique. It also allows for the training of deep neural networks with many layers, enabling models to learn complex functions and solve a wide range of problems. However, backpropagation has its limitations as well. For instance, it can sometimes get stuck in local minima, meaning it finds a suboptimal solution instead of the best possible one. Also, it's sensitive to the choice of hyperparameters, like learning rate and activation functions, which can impact the performance of the neural network. As for best practices when using backpropagation, here are a few tips. Choose an appropriate learning rate. A too small learning rate can make the training process slow, while a too large learning rate can cause instability. Experiment with different values to find the sweet spot. Use momentum. Momentum can help the algorithm overcome local minima and speed up convergence. Initialization. Properly initializing the weights of the network can lead to better convergence and improved performance. Regularization. Adding regularization, like L1 or L2, can help prevent overfitting and improve generalization. So, there you have it, Matrix. We've covered the history of backpropagation, what it is, and why it's so important in machine learning. I hope this video helps you appreciate the critical role backpropagation plays in deep learning and inspires you to explore even more in the fascinating world of neural networks. Keep learning and stay curious.